So we can see the second question, equal sum partition. What is firstly we understand the problem statement, and what are the similarity with the subset sum and odd even specification and code variation. What we have do in the code, that means that can be see here. So first of all, what is a equal sum partition? What is the problem statement? So what is the problem? Given an integer array, return you have to give an integer array, for example 1 5 11 and 5. Can we divide this array into that mean it's possible to divide this array into two halves? For example 1 5 5, the sum of the dividing into two half, the sum of this number is 11, and another dividing part is sum has also 11. So can we divide into the two half with having the equal sums? If it's possible, then you have to return the true. If it's not possible, that means we cannot divide it into the two sub array whose sum is equal to whose sum equal, then return, you have to return the false. For example, if the if 1 2 3 5 3 5, if we cannot divide this array into the two sub array, so that's why we have written its return type is a false. Understand what is the question, and then moving on the understand. So suppose anything who has divided into the two half x two half anything, for example y is divided into two half, one is x and another is also x. So x plus x equal to y, that means 2 times of the x equal to y. That means y 2 times of the x means that the given number should be a y should be a even number. So if sum of sum of the y is a even number, it's compulsory. So even a odd possibility, what they want to convey that the if given the array and if we sum of this all the value, if it give the even value, then if sum all the elements, if the return we got a even value, then we can divide that sub array. If it does return the odd value, odd value cannot be divided into two half part. So that's why its division is also only possible with the even value, not with the odd value. That's why see here we have given the integer array, and firstly I calculate the sum of that value, and from the getting of the sum it is a odd number, then return the false. That means we cannot divide the array into the sub array. If and understand the what they want to tell that the odd even specification, this thing is over and this thing is over. Before that we have done the problem, that means subset sum, that means given a array and it's we have to return the true or false if the and we also given a sum value, and we have the array two inputs type, and sum is two things are they given. We have to return that we can divide this array into we can is any array whose sum equal to, who is any sub array whose sum is equal to 11, then we have to return the true, otherwise we have to return a false. If there is no such kind of the array whose sum is 11, we have to return a false. Same thing I have to do here. Firstly I have to calculate the sum of the array, after sum of the array we have to divide the x into, if the sum is a even number, then I have to find the do the same thing which whatever I have did in the subset sum, and I have to return true or false. So if I talk about the coding part of this all the things, I tell you everything about coding. Recursive code is look like that. first what we have done, we calculate the sum of the array. We get the array and we calculate the sum of the array by applying group. If sum is a odd value, then return a false, otherwise is the sum is a even value, then I call a function of the boolean types of function hun. And in hun what we have received the an array and it's some target value whatever and a length of the array. If sum equal to, I already told you that the why I have write the sum equal to 0 at the initial state, or why I have write this sum equal to 0 n equal to 0 and or sum equal to sum is less than 0 is written the false. If this condition we have to return it false, then what I did, if sum is greater or equal to, if sum is greater than target value is greater than the current value, then I have to call this function again for the n-1, and here I also have write down the n-1 noted there. And if we have the two option, if the sum is less than, we have the two option whether I have to include it. If sum is greater than equal to, we have the two option, whether I have to include, I doesn't have to include. But if the sum is greater, sum is less than, then I have the only option that if sum is less than the current value, then I have only one single option, that I have to left the array. So if the sum is greater or equal to array of n-1, then we have to return the function of the array sum minus current array value and n-1. If we not including it, then it fun of the array comma sum n-1, else what is the fun array sum n-1. If I do the memorization code, if I told you the memorization, I have the created a boolean object array and here I declaring the array, and here I initialize the declare the array here, and here I describe the what are the size of the array. Why? Because I have to get what should be the size of the array. It should be the length plus 1 here, or the some is here, and whatever is the target value are given, it should be here, and whatever the function length, whatever the weight or whatever the things is given, that's include here, but the target value are always included here, and length and weight always be here side include row. So n plus 1 and some half plus 1, and then I here before the returning type, before the processing the array, if the sum is not null, then I have to return the boolean function are stored, the boolean what they are stored default, they store the null value. That's why it's not null, then they return this value for the current instant current value you have to store. And our table format, firstly I calculate the sum. If the sum is odd, then I have written the false, and then I have calculated the sum equal to sum divided by 2. This is the target. Then I initialize an boolean object array, and for the initialize it that if the sum or the target is equal to 0, or if there is no element, if the sum is equal to 0, then it's always possible, so fill with the it's 2. If the sum equal to if there is no element for the 0, if there is no element and if there is no element and sum equal to 1 2 3 4, for all the condition I have to return the false. So for j equal to 1 or j is less than t of the j, t of 0 of length or j plus plus, then return a false. For that value I put the false, and for this value I initialize with the true. Then for the any current instant current array, and for the current sum, if whatever I have did in the recursion there, if the j is greater than the norms of the I minus 1, then I have to fill. I have the two options, that the either I have included or either I have included, either I have to exclude it. If I including it, then I have to subtract sum by the current value, current amount. This is if j is less than, if target is target is less than the current value, then I have only one option, single option, that I have to exclude it. This thing is similar with the subset same target. By getting it, this code is converted into the subset sum problem. By converting of the getting the half value, after that this code is converted into the subset sum problem.